Looks like we're working here. Hey, this is Peter from Valley CAD. I'm the owner of Valley CAD. We're a mechanical engineering and product design firm, and we are trying out YouTube Live. We typically do TechTip Tuesday videos and Just a Thought Thursday videos, and also periodically we'll just do live streaming while we are doing some of our design applications. Like I was saying earlier, we do mechanical engineering and product design. On top of that, we also do 3D printing. We also do 3D scanning, reverse engineering applications. We do 3D CNC carving as well, drafting assistance. So we help out people from doing conceptual designs to also helping out full-on engineering teams and help them get projects done. But also on top of that, we help out with SOLIDWORKS applications. We need assistance with implementations of it, or how to apply certain features within SOLIDWORKS. A lot of companies actually give us a call, and we either do web meetings with them, or we can also come on site and do special training classes with their full engineering team. So this is our first time doing a YouTube live presentation. Pretty exciting. This will be a part of our TechTip Tuesdays, and so forgive me if there's a couple little glitches on here. As I was stating, we're still trying to test this out and seeing if it's a good route to go. Feel free to let me know if the music is too loud or if you can't hear my voice at all. So yeah, let's hop into this. In today's Tech Tip Tuesday, what I'm going to show you is how you can create linear patterns, but not just any type of linear pattern. We're also going to be working with up to reference linear patterns, and I preferably use this style of linear patterns because SOLIDWORKS will actually do a lot of the math for you. I did a live stream on this on Twitch last week showing how to use this, and we were working on a certain design for a client, and so we as I was designing it, I was hopping on and did a live stream of it, and that's also what I want to do here on YouTube Live. So we'll give it a try here. Hopefully this is going to come out properly. Feel free to leave us questions. I'm checking out my chat here. You see me, I'm looking over on my other monitor. That's because on here, if you're watching live, you can actually ask us questions while we're going. So once again, thanks for watching us. I see we got a couple viewers right now. Pretty exciting. Hello. Feel free to leave us a little pop up on the chat, say that you're here, and let us know where you're from, and let us know kind of like why you're watching these videos. So without much further ado, let's hop on over to SOLIDWORKS and let's look at this a little bit. All right, so you'll see on my SOLIDWORKS screen, simple here. We're on SOLIDWORKS 2018 here at Valley CAD, and with this version of SOLIDWORKS, I love 2018. A lot of people saw when 2016 came out, that's when they kind of recolored everything. A lot of people went up in arms about that and just were freaking out. I personally love it. You'll see that on my display though. I've made my SOLIDWORKS look pretty much like the older one. So I love that green and yellow color scheme, but if you wanted the blue and gray, it's not hard to fix that at all. So, like I said, I can tell you look over on my other monitor because in case people ask questions while we are streaming, I can quickly answer them. All right, so looking at SOLIDWORKS here, as I was stating, this video is all about coming in and doing a style of linear pattern, and it's an up to reference style of linear pattern. So, how do we go about this? Well, I'm going to start off simply on our top plane and do a simple extrusion, and we'll just do a simple plate. And this style of linear pattern is pretty powerful. So what I like to do is come in and always fully define your sketches. How do I know something's fully defined? Well, right now you'll see that I got a different color combination. I got black lines and I also got blue lines. Whenever you see blue lines, that means that it is underdefined, and that is a major no-no in SOLIDWORKS. Because what is SOLIDWORKS? Well, SOLIDWORKS is a parametric 3D modeling software. Now, I know I just said kind of a big word, at least it was for me when I first learned about it. Parametric. What does that mean? Parametric means rules. Way to break down parametric is parameters. And so SOLIDWORKS is truly known as a 3D modeling parametric 3D modeling software. And so with that, you have to apply rules within SOLIDWORKS. And how do we do that? Well, one of them is going in by dimensions, And then the other way is by adding relations. That's what these little green squares are that you see next to my lines. Relations are saying how are these lines relating to each other? Are they coincident? Are they horizontal, like you see that one there, or vertical, as you see on that one? So these are different rules that SOLIDWORKS applies while we are drawing. And it's pretty cool that SOLIDWORKS will apply them as we go. Okay, so let's make this so it's 4.5 by, let's say, 6. Okay, and we'll simply get out of this and extrude this up, let's say 1 inch for right now. And then with that, let's just say simply okay. All right, so what I want to do next is come in here, and on this face, I want to come in and let's just do a simple hole wizard. Hole wizard is a great tool. It's really useful for when you start making drawings. And what's really useful, like 2018, I believe 2017, sorry. When 2017 came out, SOLIDWORKS made the hole callout function pretty powerful where it could actually recognize standard holes. But the hole wizard has a little more power behind it than just doing a simple hole. Granted, if you're just coming in and you're just wanting to do through holes, sure, do it that way. But if you're going to be doing tapped holes or counterbore, countersink, straight pipe tap, use hole wizard. It's a much more user-friendly tool. So let's, for instance, come in here. Let's do a straight tap, and we'll do bottom tap, and we want to go off on ANSI inch. And then with that, we want to come in and say, let's do quarter 20. Okay, so now after I have that, I need to go to my position tab and drop where I want these holes to go. I know we're talking about doing a linear pattern, but I don't know. I always like showing a little more than what just the actual feature is. All right, so simply with that, I'm going to push escape once and smart dimension this. And we'll say we want to come up 0.5 and also 0.5. Like so. All right. Now we got that. I can simply just click the green check mark and I'm done. Pretty cool. SOLIDWORKS will come in. It will give me the whole diameter of what it needs to be for that quarter 20 size tap. And on top of that, it will also put in like a little dotted line around it that's saying, hey, this is a tapped hole. Okay, so linear pattern. Where this is a really useful tool is I want to take this hole and I want to pattern it, like make duplicates of it throughout my plate. And so the standard linear pattern is great for that. Now, where's this linear pattern located? Well, if you go under your features tab here and come over towards the middle of your icons, it says linear pattern. Just simply click on it. Okay, so with that selected, there we go. With that selected, what we're going to do is simply specify our direction. So I want to come in and select on this edge right here. Okay, and by default, you're going to see spacing and instances. The one I'm going to show you is up to reference. So, but first off, let's show the standard way of doing this. So we'll come in edge 1 and we'll say we're going to go off to the right. What feature do we want? Well, I want to grab this hole. So with that, I could come in and say, all right, with this, I want to have a total of 10, and let's give it so that's a 0.5 inch spacing. So looking at this, we might be going, all right, that looks good, but how far away am I from this far right edge? Well, it looks like maybe if I put 11 on there, yeah, that looks somewhat close, right? That's where we could kind of figure out like, okay, so we're doing ½ inch offset there. How long was that edge again? I don't remember. Maybe if I do an M. No, I can't do M because that messes up that. And it thinks that I'm coming in putting in an equation on there, but technically I am not. So this is where there's some complications. If you are going too fast like how I am right now and go, oh, shoot. How big did I make this plate? Stink, right? You're not sure. So that's where this up to reference function might be a little bit better for you. But once again, looking at spacing and instances. So if you're not totally familiar with the linear pattern, highly recommend get familiar with it doing spacing and instances first. And so with that, you're able to come in, tell the spacing you want in between each item. For instance, this time it's that quarter 20 tapped hole. And how many do you want? So I can increase or decrease this. So let's say 0.375 and say okay to that. Notice how it got shorter in between. So I could actually fit more holes on here. So it's a great way to duplicate an item. And it's just a standard pattern going across. So every single one of these holes are 3/8 of an inch from center to center, okay? And also I could come in and do direction 2, select this edge here. SOLIDWORKS is gonna allow me to say, all right, you wanna travel along this edge, and let's do the same sort of spacing, 0.375. Let's see how many I can fit on this one. Looks like I could probably fit 11 on there. And the reason why I can't fit as many is because I made this, I believe it was 4 inches, and I made the length 6 inches. So that's why we got 2 different patterning there. But here's a problem with this. If I say okay to this now, we'll see, sweet, we got a set of holes. But maybe I want my design intent to make it to where the holes are centered about my plate. And so right now, these holes are not centered. You'll notice that I got a big gap here, smaller one here, and my gaps from left to right, well, they might be okay, but let's see. Let's verify that. So I just activated my measure tool. So our first hole, we said make that a 1/2 of an inch, which it is. But let's see what our right side looks like. Right side says it's at 5/8 of an inch. So it's not centered at all. Okay, so that could be a problem. So this is where we come in and we do the other linear pattern. We say up to reference. Okay, so once again, as I was stating, linear pattern up to reference is in the linear pattern tool and or feature, whichever term you want to use for that. So spacing instances is the default way for any direction. You could do 2 directions at once. And also, in case you're not fully familiar with SOLIDWORKS, remember your first feature is called your seed, and every single thing after that is called an instance, okay? So just keep that sort of terminology in your mind while we're going through this. All right, so I'm gonna exit out of this, and I'm gonna use my rollback bar. I like calling the rollback bar my DeLorean. It's my back to the future bar, you know? I'm gonna go back in time right now and make it to where that linear pattern is just went away for a little bit, doesn't exist yet. So it's your time machine. So that's why I call it my DeLorean. Okay, so let's activate linear pattern again. And with linear pattern activated, this time I want to do up to reference. And on my direction 1, I want to click on this edge here. And what's up to reference, how this works is you need to specify an edge like how we did with our first one. But then you'll see I got a new cell that my cursor is actually hanging over right now, and it's green on the left side. What this allows me to do is I either come up and pick a face, an edge, or a point, or a vertex, I should say. And what we're gonna do here is actually click on this right side face. Now, why am I saying that one? It's because I told SOLIDWORKS to travel along this edge, and I haven't selected that feature yet, so you don't see it, but I'm gonna be selecting that feature. I want to have it travel along this edge up to this face. So that's why for my up to reference is going to be that face there. You'll see that it turns green for me. Great. So before we continue on, what I want to do is select the feature of what I want. So in this application, I want that feature. Great. So now looking at this, SOLIDWORKS is going to allow me to come in and it's going to say, all right, we're going to keep our point to be centroid. And right now it's set up as a distance or a spacing and keeping that consistent. SOLIDWORKS right now is going to do the math for me and it's going to say, hey, if you want to keep a 3/8 of an inch spacing between your holes and you want to go up to this face, I can fit 15 of these holes on there for you. Okay, but maybe I want to keep this so it's centered. I want to keep the hole centered on my plate. So if we look back up on our properties on the left side of our screen, we'll see here that we got our face, and then right below it, we have an offset distance. What offset do I want? Well, I want to make it so it's equal to this one. So I'm going to say 0.5, like so. So now by me coming in and saying make it 0.5, SOLIDWORKS is going to take that face and imagine that it comes in and offsets that face 1/2 of an inch in. Now looking at this, SOLIDWORKS is not perfectly 1/2 an inch from this edge. You can even see it by eyeballing it. So how can we make it so it fits on there properly? Well, in an application like this, maybe I'm more concerned about how many holes I have. Let's say, for instance, I want to try to fit 100 holes on this plate. So instead of worrying about my spacing, what I'm going to worry about is the number of instances. Because I'm going to have 10 go across the bottom and 10 travel up. So I'll simply type in 10, like so. SOLIDWORKS is going to come in for me. It's going to say, hey, if you want to fit 10 holes here and you want them to be a half an inch from the left and right side edges, your spacing is going to be 0.5555556. Okay. So for me to calculate that, like I could have done that. I could have said, all right, I believe that was 6 inches across and half inch, so technically 5 inches, and now I divide, like, I could do that if I want to, but I don't want to. I'd rather have SOLIDWORKS do that for me because I'm a human and I know I make mistakes more often than not, right? So from that, I would simply just say, let's come in and say, I need to have a total of 100 holes, and I want SOLIDWORKS to calculate that for me. Perfect. So now we'll come in to our direction 2, and I'm going to click this vertical edge like I did last time. Now looking at my vertical edge here, it is going the wrong direction, so I'm going to flip it. Okay, so because what I did last time, I said spacing and instances, SOLIDWORKS is keeping that memory. When SOLIDWORKS 2016 came out, SOLIDWORKS kept that sort of parameter set up in 2017 and 18 as well. Super cool. So in this application, I want to switch to up to reference. Okay, what face do I want to go up to? I want to go up to this top face. And with that, I want to have an offset spacing of half an inch as well. So I'll say 0.5 on that. And this time, I want to say instances again. And I want to have a total of 10. Right? Because I want to have 100 holes. So 10 this way, 10 up, we'll get 100. Now with that being said, we'll say, cool, that looks good. And then click the green check mark. So now in this parameter, with this style of linear pattern up to reference function, these holes are perfectly centered about my plate. Pretty cool, right? Now here's where this gets even cooler. I love using the term, let SOLIDWORKS model for you, don't model for SOLIDWORKS. And some of the parameters that I mean by that is I like creating SOLIDWORKS and having pre-existing geometry control new geometry, okay? And so one way we could look at that is in this linear pattern up to reference function. So let's say you design this plate with all these tapped holes in it, and you're looking at it, but now you're going, oh shoot, that 4.5 dimension is not correct. I needed that to actually be 5 inches. So what I would need to do is come in and type in 5, like so, and then push enter, do a control Q to rebuild it. Sweet, look at that. SOLIDWORKS automatically went in and kept my parameters from when I did my linear pattern and said, hey, I need you to travel along this edge and keep it so it's half of an inch off from this top edge, or top face, I should say. It's still keeping a rule of half inch on my bottom because of my original hole that I had. So that's great, right? So this is a great way for SOLIDWORKS to model for you. Don't model for SOLIDWORKS. Because if we were going off of our original linear pattern function, you'll see it here. Woo, that looks pretty bad. I'm just going to suppress that for a second. You'll see that our gap even got bigger. So I'm going to have to come in here and go, all right, 0.375. Oh man, maybe if I make that so instead of 0.375, we could say, let's make it so it's half of an inch. Yeah, that's going to fix it, right? Control Q. Oh, not good, right? Now I got to go back in, do some more math on there, and make other mistakes. Not the best route, right? So that's why I like to use the up to reference function. It allows SOLIDWORKS to calculate it for me. It's a really useful tool. So if you know that your parameters are saying, hey, I want to make sure I have 100 holes, they just need to be equally spaced on this plate, I don't care about spacing in between each one, you're good to go. And so what's really cool is after you do that pattern and you say, oh, I don't need 100, let's bump it down to 81, so 9 by 9, and say okay to that. SOLIDWORKS is going to automatically update that for me. It's going to keep these holes half an inch off to the side. Now, let's say we want to make SOLIDWORKS even a little more smarter. And what I mean by that is, what if I need to change this hole to come in 3/4 of an inch, right? Well, what we can do is come in and say, all right, this hole here, let's make it to where this dimension here is going to be equal to that one there. So I just created an equation. Control Q. So if I ever change that dimension there, it's going to automatically update that one. They're linked to each other. Pretty awesome. Now I want to do that for my linear pattern here. So as I look at double clicking on LPT or LP pattern 2, you'll see I have dimensions that pop up here. Now, there's one thing that I've caught with SOLIDWORKS 2018 here that it's a little frustrating. Thinking of creating a SPR for it, or an enhancement request, I should say, and see if SOLIDWORKS will fix this or if they have an SPR for it yet. So what I want to do is come in and I want to make this 1/2 inch equal to the 1/2 inch of my original sketch. So how do we go about that? Same application. Simply double click on your whole of your linear pattern, double click on that 0.5, push the equal sign to activate the equation function within SOLIDWORKS. Come back over here, double click on your seed hole, see your 1/2 inch there, say I want to make it equal to that, do a Control Q. All right, so now with that, if I came into my first sketch, sketch 2, and said, hey, I don't want that to be 1/2 inch, instead I want to make that 0.375, so 3/8 of an inch, push Control Q. Oh, Control Q. There we go. You'll see that these holes just got shifted down and also it got shifted over. This just made my SOLIDWORKS part extremely smarter, right? And it's letting SOLIDWORKS model for me. Because if I did not do that equation, I would have to come in, update that dimension, and I'm like, oh yeah, that looks good. I might forget to come over here and fix this dimension. So as I was saying about 10 seconds ago, I found a scenario within SOLIDWORKS where it actually was popping up with an error. And it's an error that shouldn't be popping up. So once again, probably create an enhancement request with SOLIDWORKS saying, hey, fix this. SOLIDWORKS does listen, by the way. You know how I'm coming in and double clicking on that dimension and activating the equal sign to activate the equation function within your modify box? Actually, one of my previous coworkers, he was one that created that enhancement request, and SOLIDWORKS 2014, I believe, was implemented with that. So it's much easier than having to come in, go to your equations folder, and say, all right, let's make a new equation. You know, right click, manage equations here. Have to have this window up in front of your screen and try to put in those equations. It's kind of dumb, right? So SOLIDWORKS finally listened and made it to where if you type in the equal sign, it'll activate the equation function for you. Super awesome, okay? So here is the little hiccup that I'm seeing within SOLIDWORKS. You know, I'm double clicking on here and I want to add another equation to this guy here. Look what SOLIDWORKS does to me. I type in equal, and let's say I want to make it equal to this guy right here. Say okay to that. SOLIDWORKS for some reason pops up and says, please enter number greater than or equal to 1. I am not sure why SOLIDWORKS is doing this, and once again, this is why I want to create an enhancement request with SOLIDWORKS to say, hey, the intention of this software is not working as intended. So what the heck? So hopefully we could get that resolved. There might be an SPR out for it already. I might be one of those weird guys that found out about it and no one's told SOLIDWORKS yet. So once again, highly encourage you, if you are current on your subscription, let your VAR know about it. Like call up tech support and say, hey, I was watching this awesome live stream from Peter at ValleyCAD and we found a hiccup. I want to be the guy that turns that into SOLIDWORKS so that way I get all the credit for it. You could do that. You could beat me to it if you want to. Good try, or good luck if you want to try that. So yeah, that's one little hiccup I found with it, and I've tried other scenarios where I said, oh, maybe I need to make it so it's equal to that dimension there. Nope, if I type in equal and say equal to that, SOLIDWORKS gets mad at me. So maybe I can say do that and say -1. Nope, still doesn't work. So there's got to be something on here that can fix that. I've also tried coming in here, say manage equations, and we'll say whole HO for a whole offset, and we'll just give it a 0.375 like so, and we'll just call this whole offset. This is called a global variable that I'm creating, and global variables are awesome. So instead of making that equal to this, what I want to do is say take D1 at sketch 2 like so, and I want to make that equal to the global variable HO. okay? And then I'm going to come in here and say make each of these equal to HO, and also make this one equal to HO. So if I came in and see how these are all calculated at 3/8, if I came in and said, hey, make this 0.5 way up here, it's going to update all these here. So if I say okay to that, do Control Q, you'll see that all these guys got updated to 1/2 inch. And they all have the equation symbol on it. Pretty cool, huh? So that's one way to go. So if I came in here now, double clicked on this hole, and said, all right, let's make it so that that hole equals to the global variable of HO for hole offset, SOLIDWORKS is still going to come up with this number needs to be greater than or equal to 1. So unfortunately, due to this, SOLIDWORKS is not going to play nice with me on it. I've tried other variables. If you know of another way to fix that or work around that, leave us a comment. Let us know. Like I'm learning something new in SOLIDWORKS every day, and I try to learn something new every day. That's why I end every video saying, hey, make sure you go out and learn something new. So a little more of my background, like I'm the owner of ValleyCAD, and on top of that, I have my degree in computer-aided drafting design, and I'm actually a certified SOLIDWORKS expert. And so there's roughly 3,500 of us in the world. And so look at that, and there's roughly 5 million SOLIDWORKS users in the world, supposedly. So I've worked really hard to become a certified SOLIDWORKS expert. I love this software, as you guys can tell. And so once again, this is our first time doing a live stream on YouTube. Pretty awesome. I believe it's coming across okay. Once again, we got 2 watching. Thank you very much. Loving the comments on here. So once again, my name is Peter Estes. I am the owner of ValleyCAD. Said that a couple times now. Spread the word about ValleyCAD in our YouTube channel, actually. We try to post new videos, as I was stating earlier, every week. We try to do TechTip Tuesdays as well as Just a Thought Thursdays. And so we'll be posting another video tomorrow. I know today's Wednesday. TechTip Tuesday should have been yesterday. We had a phenomenally busy day yesterday. It was amazing. Had a couple great meetings and so forth. And some of those meetings I'm hoping to make public here in the next month or so. Have some awesome things in the works that will be extremely beneficial for our clients as we are growing. So once again, thank you for watching this live stream. Please give us a thumbs up, like and subscribe to our ValleyCAD channel here. Also, check out our website. We are www.valleycad.com. And on there, you can see all the other services we provide as well. So, like I said, we do mechanical engineering and product design. But on top of that, we do drafting. We help out engineering companies with getting projects done for them. We have the opportunity to do everything from designing sunglasses to designing helicopters and cars. That's how much fun we get to have here. And we're bringing these services to the Central Valley here in California. We're actually located in a little town called Reedley. We're about 45 minutes south of Fresno, actually. And so highly encourage you guys, check out our website, check out some of our other YouTube videos. If you got questions, feel free to shoot me an email. My email's on our website and so forth. You can also call me directly if you'd like as well. So once again, thank you so much for watching this. Have a great rest of the day, and make sure you learn something new. See ya!